Okay, in our last lecture actually we saw that the big outer measure is a measure if we have two disjoint sets and one of them is open interval. Okay, so now today our case is that if A intersection B is empty and B is open set, then the big outer measure of A union B is actually A plus B. So one way is obvious, so proof. So definitely, obviously we have A union B outer measure is less than or equal to. So we need to show that A plus B is less than or equal to A union B. And always for sure, the measure of A will be finite. Otherwise, we will have infinity is equal to infinity. So if B is open, we know that so any open set can be written as a union of disjoint open intervals. Okay, so since B is open, so B can be written as a union of disjoint interval where Ik is a sequence of disjoint open intervals. Okay, now so since B is union of disjoint open intervals, so we can say that, okay, so what we think about A union of K is equal to 1 up to Nik. So this is nothing but this is A union I1 union I2 union up to so on union In. And now since each I1 I2 and up to In they are open intervals, and our last result we saw that, okay, if we have open interval, then the measure of A union B is actually measure of A plus measure of B. So this will be A. Okay, so this is measure of, okay, so this is measure of, I would say A union I1 union I2 union up to so on union In minus 1 plus In. So by induction this will be eventually plus sum of K is equal to 1, okay, I K. Okay, now also we know that A union of K is equal to 1 up to Nik is contained in A union of K is equal to 1 up to infinity Ik. So then by monotonicity what we have A union of K is equal to 1 up to Nik. The outer measure is less than A union of K is equal to 1 up to infinity Ik, which is A union B. Okay, now but the left hand side was A plus sum of K is equal to 1 up to N. Okay, so this is Ik and this is less than A union B. Now so if N approaches to infinity, then we have A plus sum of K is equal to 1 up to infinity and Ik outer measures in their interval, so which can be written as length of Ik, and this is less than A union B. We are almost done, but now we need to know that actually the sum of K is equal to 1 up to infinity, length of Ik is nothing but this is measure of B. To see that, so what if if my A is empty set, then what I will have then, so if my A is empty, so then definitely I will have sum of k is equal to 1 up to infinity. Length of ik is less than measure of b, outer measure of a. And also, since b is actually union of k is equal to 1 up to infinity ik, that is b is in contained in union of k is equal to 1 up to infinity ik. So by monotonicity, this means that this is not by monotonicity, the outer measure will always be less than sum of length of ik whenever b is contained in the union of ik. So now by this, what we can say from here, we say okay, that sum of k is equal to 1 up to infinity length of ik is actually outer measure of b. So then a outer measure of a plus outer measure of b is less than outer measure of a union b. Hence we prove that a union b is measure of a plus outer measure of b. So we proved another result. So first, if we have two disjoint set and one of them is open interval, and the second case we saw that okay, if the one of them is open, then our Lebesgue outer measure is a measure. And thank you. I will see you in the next video.